Well, if we just do a little bit of a recap. So probability, the study of probability, is really about one main formula where we say the possible outcomes, so the number of possible outcomes, so I'll say n, and the number of favorable outcomes. So, for example, the probability of throwing a 6 on a dice, there's 6 possible values, but only one of them is a 6. So that was the main formula. And then after that, there were a couple of other identities that we learned about. And then after the other identities, we learned about something called a Venn diagram, which helped us to visualize all the favorable and all the possible outcomes for different situations. So that's what we did going back in this course with previous lessons. And then in the last lesson, we started something called tree diagrams. And tree diagrams also help us visualize what are the possible outcomes, what are the favorable outcomes. Now, if you feel like you have a basic idea about tree diagrams, give me a thumbs up. If you feel like you don't really know what's going on with tree diagrams, give me a thumbs down. I just want to have a quick little check-in with the class. Okay. So it's about 50-50 if I look at the thumbs coming in the chat. And so I think what we need to do is do a nice slow example with showing you how tree diagrams work. So let's look at this question. The question says, drawing and replacing. And the situation is a bag contains 12 red balls and it contains 5 blue balls. So these are just balls that are inside a container of some sort. So I can even draw a container and to draw 1, 2, 3, 4, 6, 10, 11, 12. And I suppose I could put red, 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 red. And then there's another 5, 1, 2, 3, 4, 5, and these are blue. And we mix them all together, let's say, and now we have to do some decisions. So it says a ball is drawn at random and then replaced. So we put our hand inside here, put our hand inside, and we take out a ball and it is something. And then we put it back, and then we draw another ball. So we've got 2 balls. What is the probability that both balls are red? Now, this is a little bit confusing to kind of get your head around how many choices do you have? And so what we do is we represent the first choice as a branch on a tree. Now, what are my 2 choices? I want to ask in the chat, what are my 2 choices for the branches of the tree? For my first choice. Okay, so it's going to be red, or it's going to be blue. Now, what do you think is more likely on the first choice? Do you think that it's more likely I'll get a red, or it's more likely I'll get a blue? Now, I see lots of students are saying in the chat that red is preferable, and I agree because there's 12 red. Now, in total, there are 17 items in here, 5 plus 12, but you have a 12 out of 17 chance of getting red on your first throw, and you have a 5 in 17 chance of getting a blue. So it's more likely that you'll get a red than a blue, but you also have a second choice. Now, what are my choices for my second choice? What are my choices for my second choice? It's still going to be red and blue. Red, red, and blue, blue. Now, for the second choice, because it says here, a ball is drawn at random and then replaced. When we say replaced, we literally mean that it was replaced back inside the container. So what is my probability of getting red on the second throw if I literally put whatever ball I got back inside the container? So these events are independent. They don't affect each other because you put it back. So it's still going to be 12 out of 17 here. And the chance of drawing blue is 5 out of 17. And then the same one down here and the same one down here. Now notice how I write on the branches of the tree, I write the probabilities. Now, the question I asked at the beginning, what is the probability that both balls are red? Using probability notation, we could say probability of RR. Now, the problem we have here is there are 4 possible outcomes. We can go, the tree shows you red, 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 blue, blue, red, blue, blue. But they're not equally likely. The reds are far more likely to happen than the blues. And so we can't just say there's a 1 in 4 chance. What do we need to do to figure out the probability of getting that both balls we draw are red? And we did a little bit of this in the last lesson. What do I need to calculate the probability of getting red and then red? Okay, you multiply along the branches of the tree that conform to this outcome. So what is the answer going to be? It's going to be 12 out of 17 times 12 over 17, which is 144 over 289. Now, if you put that into a decimal, which I could do here, 144 divided by 289, you get 0.498. So it's about 0.4982. So, you know, it's getting pretty close to 50% chance of getting 2 reds in a row. Okay. Now, what we're actually doing, the formula that we're using is because these events, drawing the first draw and drawing the second draw, are independent, we're just actually using the independence formula. So like here, it's like saying, what is the probability of getting red and red? So A and B, it's just the probability of getting red the first time times the probability of getting red the second time. So we're using this independence product rule to help us. Now I saw someone's hand go up. Whose hand went up now?
It's Keisha.
It's mine, sir. Okay, so
How can I
mine, sir.
Good, good.
Say, why is it 12? Why is it 12 over 17 times 12 over 17?
Because the question says, what is the probability that both balls are red? And the only way to get red and then red is to follow this path on the tree. So let me ask you another question to help you and everyone else here. What is the probability of getting blue and then blue? What do you think the probability is of drawing a blue on the first time and a blue on the second? What do you think, Keisha?
Sorry, can you repeat that?
Yeah. So what do you think the probability is? So say you're drawing balls out of this hat, and I'm asking you now, what's the probability that you get a blue on the first go and a blue on the second go? If you look at the draw, look at this pathway. Can you see this first pathway to blue is 5 over 17?
Yeah.
Okay, now.
So it's going to be 25 over 289.
Okay, so yeah, so you're basically going to go 5 over 17 times by 5 over 17, which is going to be 25 over 289. And in decimal land, it's going to be about 0.0865.
086.
So can you see how this is
087, sorry.
it's far less likely than getting a red. Okay, cool. Let's go.
Thank you.
Pleasure. I'm glad I could help. Let's go to another one. Let's have a look at this one. They've actually drawn this for us already. So it says here, a jar contains, let me blow this up for you. A jar contains 7 red discs and 4 blue discs. 2 discs are selected and then replaced. This means the first disc is returned to the jar before the second disc is selected. Are these events independent? Yes, they are. Okay, and the reason they are is that the outcomes are exactly the same. There's no change in the likelihood of either of these. So if you didn't put it back, then you would be affecting the second one. But in this case, because you replace it, the events are independent. Now, they have got this tree here to take into account the information. I want to know in this question, what is the probability that the 2 discs are red that you draw? And then I want to know what is the probability that the first disc is red and the second disc is blue. So give me the answers to those 2. Pop it in the chat. So what have we done? The red is this path. The second one is the first disc is red, but the second one is blue. So that probability is going to be 7/11 times 4/11, which is 28/121. There's a question. Can we unmute Relo Bukhadi? Can we unmute Relo Bukhadi? Yeah.
Yes, sir.
How's it going? What can I do for you?
I would like to know, like, what are the odds that I would have to plot a tree diagram when it comes to a question, like this in the exam or test?
It's quite likely. It's quite likely. So sometimes they give you the tree diagram and you answer questions, but a lot of the time you have to draw it yourself. So it's pretty likely, like 80% chance. Yeah.
So I'd have to draw, like, exactly like maybe the way this question is plotted.
You don't have to draw. Yeah, so you normally have to show the branches and then you show outcomes, and then on the branches you draw the probability of that event happening. So there's a 7/11 chance of drawing a red. Okay. And a 4/11, which comes from the original question up here.
Yes, my question was not basically my question was basically the format of the.
Oh, the format. Look, it's not okay.
That I would have to
yes.
Draw, then calculate maybe 7/11 over multiply by 7/11. You see,
yeah.
that I would have to do all of them.
You look, if you can miraculously get the answer correct without a tree diagram, it is possible that you'll get most of the marks. But as they get more difficult, the tree diagram is really a good idea to get used to doing. So let me say that, because it's not impossible, but it's highly recommended you do a tree diagram.
Okay. Okay, sir. Thank you.
Cool. Let's do the next two. So what is the probability that only one of the discs is red? Now, I think there are two possible favorable outcomes here. You need to know the probability of getting red and then blue, or the probability of blue and then red, and then add them together, because only one of the discs is red is going to be these two possible pathways. So let me highlight them here. That one is one pathway, and then the other pathway where only one of them is red is that. So what you need to do is you actually need to add these two probabilities together, because both these pathways describe a favorable outcome. So find me the answer to that. What's that going to be? We kind of know the first part. So that's going to be 28 over 121. But now the probability of blue and then red, oh, well, that's also going to be, now that I think about it, it's going to be 4 over 11 times 7 over 11.
Yeah. Sorry, sir.
Yeah.
Sir, may you please explain again how to get the answer to number 3?
Yes. Okay. Do you notice that only one of the discs is red is the condition? So only one of the discs. In this combo here, would you agree that the first one is red, the second one is blue? Would that be, are you happy with that? Okay, then in this next one, we have blue and then red, and that's also, so what you need to know is what is the probability of this path? It's 7 over 11 times 4 over 11. What's the probability of this path? It's 4 over 11 times 7 over 11. And both of these are going to give us 28 over 121. And so my final answer is actually going to be to add those two together, and you get 56 over 121. Okay, I'm not going to do the fourth one right now because I want to get a chance to practice this same idea again, but you should be getting 56 out of 121. So let us go let's do this one. Okay, last one before the break. 2 identical bags are filled with balls. So we have 2 bags. We'll call it bag A, and we call it bag B. Bag A has 3 pink balls. So P for pink. And 2 yellow balls. 2 yellow. Bag B contains 5 pink and 4 yellow. Now, that is my setup. It is equally likely, that bag A or bag B is chosen. So maybe I should just draw a quick little tree diagram. If that is bag A and that is bag B, what is the chance of choosing bag A? What is the chance in probability of choosing bag A? It's going to be a half, yes, Morgan, or it could be 50%. But I'm going to say a half because each of these options is equally likely. Okay, now it says, a bag is chosen at random, and then a ball is chosen at random from the bag. What are the 2 possibilities for the colors in bag A? What are the 2 possibilities for the colors in bag If we look at this thing over here, what are my two possible colors? So it's going to be pink and yellow, or yellow and pink, whichever order you want to do this in. So pink and yellow. Now, what is the probability of choosing a pink ball in bag A? So tell me, what is the probability of getting a pink ball in bag A? Look at the drawing and look at the colors and see what you notice. So 3 out of the 5 possible bags. So if you're choosing one, there's a 3 in 5 chance of choosing pink. And the chance of choosing yellow is going to be 2 out of 5. So we write it on the branch. Annie has asked, why are the bags labeled as a half? Because it says here, Annie, that it is equally likely that bag A or bag chosen. So if it's equally likely, each of these bags have a 50% chance of being chosen. The hand chooses that half the time and that half the time. Okay, now let's draw the possibilities for bag B. I think it's still going to be pink and yellow, but I want to know, what is the probability of choosing pink in bag B? So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 in total, but there's a 5 in 9 chance of choosing pink, and the chance of yellow is 4 in 9. Okay, now, this is what I love about tree diagrams. You have all the possible choices available to you in this lovely, beautiful drawing. What you need to do now, so it says represent the information by means of a tree diagram. Clearly indicate the probability associated with each branch of the tree diagram and write down the outcomes. So the outcome over here is bag A and then choosing a pink. Bag A, then choosing yellow. Bag B, and then pink. Bag B, and then yellow. Now, I want you to work out for me, what is the probability that a yellow ball will be chosen from bag A? Who feels like they can do that one? Ask yourself, which pathway is a yellow ball chosen from bag A? It feels to me like if you're going through bag A, you go here, and if you are going to get yellow, you end up here. Now be careful, what do we normally do when we have to make two choices? Remember, these events are independent of each other. So Conke has asked, how did I get the half? So Conke, the half comes from the fact that it said in the question, it's equally likely that bag A or bag B is chosen. When we say something is equally likely, it means that bag A has a 50% chance of being chosen and bag B has a 50% chance of being chosen, or a half. Now, yes, absolutely. When you are going along the branches of the tree, you have to multiply. And so the probability of getting a yellow from bag A is going to be a half times 2 over 5, which is 2 over 10 or 1 over 5. All right, now, the second one is, what is the probability that a pink ball will be chosen? It doesn't say anything about, which bag. It just says, what's the probability that a pink ball will be chosen? And I want you to try and do this one by yourself. So see if you can work this one out for me. How many branches of the tree do you think are favorable? How many branches do we think are favorable? Well, there's definitely a pathway which goes like that and gives me pink. But there's also a pathway. Well, let me use pink just to be, right? So you can get to pink going like that, but you can also get to pink going like that. So don't you need to add the two outcomes together? So you need to know the probability of ending up with pink is both these branches. You could get a favorable outcome here or here. And so what you need to do is go a half times 3/5 plus a half times 5/9. And I'm going to use my calculator because I can. And I'm getting 26 out of 45. So there's a greater than 50% chance that you'll end up getting a pink ball when you choose from either of the bags. When you randomly choose one item from either of the bags, there's a greater than 50% chance. And that makes sense because there are a lot more pink, well, there are more pink balls in both bags than there are yellow. So it would make sense to me. Okay, give me a vote, thumbs up if the idea of a tree diagram to understand outcomes and favorable outcomes is starting to make sense to you. Give me a thumbs down if you are feeling uncertain or unsure about something here. Okay, well done. It's not too bad. Like you say the outcomes, then you say the numbers, and then you look, what are the paths that I need to do? Okay, let's have a break because we've been working hard. And so what I want to see is I want to see the cameras on and I want to see students on their feet, giving their brains a break. Let's just relax for a second. Let's just roll our shoulders a little bit. So roll them backwards. And we'll roll them forwards. Okay. And then we're going to rotate a little bit. So just a little bit to start with. Oh, double click. And then we go a little bit further. Okay. And then let's do some small circles with our arms. Small circles, and two big circles. Let's go backwards with big circles. And let's go back into small circles. Okay, shake out your arms, make them nice and flappy. And let's do a tricep stretch. It feels good. And then let's switch to the other arm. Okay. And then just make your arm nice and flappy again. And maybe shake out your legs as well. Okay. Let's do some heart rate raising stuff. And I'm feeling energetic today. So let's do some jumping jacks. Let's do 20. Okay. 3, 2, 1. Let's go. Halfway. And whew, that's on that. That's some quality right there. Whew. And while we are all catching our breath, I want to see if anybody can get the Maths 24 puzzle for the day. So we're just trying to, whew, there goes my breath. We're trying to make 24 using these cards. See if you can make 24 using the numbers on the cards. Who feels like they know? How do we get to 24 using 1, 8, 8, and so Jaden has said for blue, 7 times 3 plus 4 minus 1. And Keisha agrees. And then if we add all four, Tando? So Sadiq agrees. So blue has definitely been taken down by the students of grade 11. What about the red one? Can you do the red one? I think, how would I do the red one? Ooh, it's a bit sneaky. 8 times 1 is 8. 8 times 4 is 32 minus 8. That's clever, Malcolm. 8 times 1 is 8. So you've done those ones. Then you go 8 times 4, which is 32. And then you take away 8 from that to get 24. Well done. That was pretty good. Okay, everyone, I hope you enjoyed the brain break. Give me like a muscle emoji or an exercise emoji or a smiley face if you had a good brain break in the chat. Yeehaw. Yeehaw. I like it. Awesome. Come on. Okay. Now, since you guys are all been rejuvenated by your brain break, we are going to look at drawing without replacing. Now, I want you guys to think about what might happen to my tree if I take out a ball and I don't put it back. Do you think the events of drawing a ball are going to be independent of each other? Or if you don't put it back, are they going to actually affect each other? What do you think? Okay, I love it. So some people are saying decrease the number. Some people are saying dependent. You're right. The second one, in some senses, depends on what you get from the first one. So I want you guys to have a go at this. I'm going to give you a little bit of help. You're still going to have two possibilities. The first one is going to be red and the other one is going to be blue. So that's not going to change. But what's different is that's your first go. On your second one, you're still choosing from red and blue and red and blue. But what's different this time is you're not putting it back in the box. So let's start with the very first one. What is the probability of getting red on the first throw? So actually the first throw has to be the same because nothing is different. So my very first throw is going to be 12 out of 17 and 5 out of 17. So nothing really changes in this part, but the second part is a little bit different. If you've taken out one of the balls and you used to have 17, how many are left in the bag after taking out one thing? Okay, be careful. Remember, you start with 17, but you've taken one out. So now if you take one out, you're only left with 16 to play with. Okay, but so I want to suggest that when you are drawing on the second go, there are only 16 balls to choose from. Give me a thumbs up if you get the idea of why it must be 16 if you're not replacing the ball. Okay, now, if you drew a red on your first go, how many reds are there left to choose from in those 16 that are left in the bag? How many reds are left? If you chose a red the first time, You had 12 to start with. So actually, reds are going to be 11 out of 16. And that's the sneaky bit. Can you see how it went down by 1 and down by 1 here? Now, when we come across, so what happened was, because you chose your first round and you got a red, there are only 16 left inside the bag. And of those 16, there are only 11 red ones that are left. Now, there's two ways of doing this next bit, but I think you'll all agree this has to be out of 16. What do you think the number for the second, what do you think is going to go above the 16? Okay, it's not going to be 4 because you chose red the first go, so you didn't affect the blues. So there must still be 5 blues left inside the hat, right? You only took out a red, so the blues were left untouched. Okay, so this is the slightly more difficult one where you actually have to adjust the numbers here. Let's go down to this next level. If you chose blue on the first go, how many numbers are left, or how many balls are left in the bag? There's still going to be 16 left in the bag, but how many? And now what's going to happen is, okay, what is the probability of choosing a red? Well, how many reds are left over here? I'll make a square. How many reds are left here? Well, because you didn't get a red on the first go, all 12 are still left. So you get 12 out of 16. And then on the bottom here, this branch is still going to be over 16. But what's going to be, you chose blue the first round, so what's left of my choices? Well, there were 5, but you took one out. So this is 4 out of 16. And this is called drawing without replacing. And the first and second throws are not independent. They depend on each other. So I want you to answer this question. What is the probability of getting a red ball, taking it out, and then choosing a red ball on the next go? Let me know in the chat, or let me know in the chat what you get. So for me, the pathway has to be red and then red. So we get 12 out of 17 times by 11 over 16. If you look along here. Now, if I put that into my calculator, the calculator is saying I get 33 over 68. And so the probability of getting red, taking it out, and then another red is 33 over 68. Give me a thumbs up if you followed that example. Give me a thumbs down if you didn't follow it. We're going to do another one now, so don't worry if your thumbs are down. I just want to make sure that's okay. Let me ask you one more. What is the probability of drawing a red on your, no, what's the probability of drawing a blue on your first go, not replacing it, and then getting a red? What's the probability of that going to be? So we should be getting 15 over 68. Okay, cool. I like what I'm seeing, Konke and Tojovatso and Komali. I like it. I like it so much. I think you guys are ready to squeeze one more in before the end of today. So let's go to a old exam question. So here is your all exam question. A bag contains 3 blue marbles and 2 red marbles. A marble is taken from the bag, the color is recorded, and the marble is put aside. So it's not put back. A second marble is taken from the bag. The color is recorded and then put aside. Draw me a tree diagram to represent this and calculate the probability of first taking a red marble and then taking a blue marble in that order. So over to you. I will take questions, but I want you to try and answer that question for me. See if you can draw the tree diagram and be and then if you have a question, don't be afraid to ask, and we can chat further. So these, Sadiq, these events are dependent, and because they're dependent, you have to change the probabilities. So I do think it's going to be blue and red to start with. And then you're still going to have choices for blue and red for the second round. The first choice is going to be easy compared to the second choice. The second choice takes more thinking. But I'd say the first choice, there's a 3 in 5 chance of getting blue, and then a 2 in 5 chance of getting red. Now, where the thinking is really going to come in for you guys are these next branches. And so I'm going to give you some more time for that. Remember, you're not replacing them, you're putting them aside. And so the first choice affects the second choice. Now you had 5. Now I'm pretty confident then you should have 4 as your denominator. So like all of these are going to be out of 4. Because you know that the only 4, if you choose 1, there's only 4 left in the bag. The question is what goes with this? So if there were 3 to start with and you chose a blue, there are only going to be 2 left over here. If you chose a blue, you haven't affected the red, so this must be 2 out of 4. Kumaik, what question do you want to be clarified? This branch over here. Just give me a bit more detail and I'll see what I can do to help. If we go to the next part, if I choose a red on the first go, there were 5, so there's 4 marbles left, but I took one of the reds out. But does that affect the blues? No, there's still 3 blues sitting there. And if I chose a red on the first go, well, there were only 2 to start with, so now there's only a 1 in 4 chance. You also notice that these 2 numbers always, these 2 splitting branches always add to 1. Now, what I wanted to know was what's the probability of first taking a red marble and then a blue marble? So I have to start out in life on this path, and then I have to take a blue marble. So for me, this is the only outcome that's favorable for this question. So what's the answer to that going to be? The probability of getting a red and then a blue. So that should be 6 out of 20 or 3 out of 10 or 30% chance. Okay, so it's not so bad. Give me a thumbs up if you're following my, now we're doing this dependent probability, but where the tree diagrams are a bit more tricky. They're a bit more tricky now. Okay. Let's do one more. Not that one. Not that one. Actually, I think we can call it. Okay, well, let's do one more. We're just going to do one more, then we're done for today. So we're not going to do this whole question. We're just going to do two red cubes. So all I want to know is what is the probability that two red cubes are taken. A bag contains one blue cube. It contains two green and three red. One cube is taken at random from the bag. Its color is recorded and it's not replaced. A second cube is then taken. Now, what's going to be different about this one is you have three choices, which is blue, green, and red. And then you will have three choices for each of these branches too. Blue, green, and red. All I want you to do is I want you to work out the probability that two red cubes are taken. So you don't even have to do the whole tree. You just have to do the pathway that is relevant to two red cubes being taken. Can you see which branches you need to fill in? I'll give you some time. So I suppose I need to know how many items there are. So there should be 6. And so the very first branch says there's a 3 and 6 or 50% chance of getting red. But I don't want to know the probability of just getting red on the first throw. That would be first, that would be second. I want to know that the probability of getting 2 red cubes if after the first draw I don't replace it. And for me, that feels like I have to go down this pathway. But that means I need to figure out what goes here. Now, how many balls are left in the bag if I had 6 to start with and I take 1 out? Well, there can only be 5. How many of them are going to be red if my first choice was to take a red out? Well, because there were 3 to start with and I took 1 of them out, that's 2. So what is my probability of getting red? What is my probability of drawing a red, not replacing it, and drawing another red? Well, I see 3 over 6 times by 2 over 5. And I'm going to get my handy friend, the calculator. And I get 1 in 5, or you could even say 2 in 10, or you could say a 20% chance. So there's a 20% chance of getting all red. Okay, and we're going to call it a day for today now. You guys have done very well. Just to recap what we've done today, we've looked at how we can take probability questions that involve choices and represent them on tree diagrams. On a tree diagram, you have the outcomes on each branch or at the end of each branch, and you write the probabilities on each branch. Okay, so I hope that you enjoyed today's lesson. I see Ms. Kia has already put the poll up, which is very helpful for us to get feedback about how our students found the lesson. So please do fill that in. And yeah, I hope you enjoyed today's lesson. So if we complete the first branch, would the second probability be? I'll have a look at that now, Annie. So the blue one would still be out of 5. And because there was only one blue ball, I think, it would just still be 1 out of 5.